right, everybody. We are here, and we're going to listen to Tom Wilhelm give us a wonderful presentation on exploiting AI in machine learning systems. You want this one or you want that one?
Oh, this works.
That one?
All right. Thank you. So we obviously got the diehard hackers here. So thanks for showing up for this so late in the day, and especially considering how nice that weather is out there, right? So definitely appreciate it. So I'm going to apologize now because this talk isn't an hour long. This talk is more like multiple hours or multiple days, right? Because it can get really in depth. So all I'm going to be able to do is kind of touch on the highlights and talk at a higher level. I will talk about some of the stuff that I really think is cool and has a major impact within AI and our lives, right? So again, I apologize for trying to cram too many days worth of data into just 1 hour. But yeah, so with that in mind, feel free to ask me any questions. I don't think we have a chat session outside, but feel free to reach out to me. I'll have an email. I have a Discord server. Happy to chat, happy to do live chats, whatever. So anyway, let's go ahead and get going. All right, so a little bit about me. This is very brief. I've been in information security for over 35 years. I've been a hacker for over 2 decades. I am a published author. This is the latest book. I'm doing a little pitch here. This just came out in January. It's the 3rd edition of the Professional Penetration Testing course. It's my 6th book, and I'm actually really proud of it. I think I did a really good job. And there's also some online components to help with the training in the book as well. As you can tell, or you can guess, I've hacked pretty much everything in some form or fashion. I've done, the web apps. I've done networking, red team, you name it. IoT have been involved in that. So yeah, happy to talk about any of that as well. The email address, Tom@PentestTV, that's where you can reach me. Like I said, if you have any questions, just take a quick screenshot on your phone or type it in and then ping me later. Happy to chat. Also add me to LinkedIn. You guys are all my friends. Let's just connect, okay? Okay, so it's not fair that I would get up here and say what the situation is with AI and some of the attack vectors and et cetera without at least AI providing some feedback to. So I asked AI exactly what is AI and what ChatGPT is and a LLM is and things like that. So it gives me this information, and I think it's pretty accurate. But the thing I want to point out, and I highlighted at the very top, is it's supposed to make decisions. That's the key, right? It's not just supposed to regurgitate information. It's supposed to take what it has and make decisions to us, provide that input, or whatever program or sort of architecture that it's supposed to support. All right, so that's the key thing, making decisions. Now we're going to talk about AI a lot, and I asked AI what it thought it looked like. So this is actual picture that ChatGPT provided itself, and you can tell that it's actually very caring and benevolent, right? So in its mind, it has this view that it's here to help the world. So I asked it to describe me. What do I look like? I gave it all of my information, and this is what it thinks I am. All right, and all of us, right? So obviously, we're very scary hackers, right? And the truth is that we make AI. We put it in a position where it's very difficult to be effective, and we'll go through all of that piece by piece, and you'll see why. And I'm going to give you a hint at the very end. I'm going to say it's easy for us to hack, extremely difficult for AI to prevent us from hacking. But you'll have to stick to the end to understand what I'm talking about. Okay, so let's talk about some real world exploits. I love these graphics. I mean, I really do. Apparently, we're doing reap fakes and owl hackets. So AI has a different interpretation in its own language. So I'm just going to show it up there for you guys to see. But all right, this is the very first one. These are the cool things that you've heard about or really show an impact on how hackers influence and undermine AI. All right, so this is a Tesla. They did a few different types of tests to see if they can circumvent the AI. And I don't know how well you can see it, but there's two little stickers out there. They're about that big. And basically what it did is they put it on the road, and the car thought it was a lane change. And so the car pushed over. So cheap little stickers, throw it on the road. At that time, before the patches, you could push the car into oncoming traffic. All right, pretty important. Another thing that you could do is you could activate the windshield wipers because it thought it was raining. And then the other one was put stickers on the speed limit signs. And all of a sudden, it's no longer a 45, it's an 85, right? And so the car interprets that and goes that speed. So it's kind of crazy what just little things we can do to impact and disrupt the thought process of AI. Okay. And I do have, let me back up one more time before we get too far. All these slides are going to be on that Pentest TV website. So I'll have the information, the slides up there. I'll have a blog posted as well. Give me till what, mid next week or end of next week? Because yeah, I think I'm going to need to recuperate or at least enjoy this weather a little bit before I get to that point. So, but it'll be up there, I promise you. Okay. All right. So Microsoft, here's the other fun one. Microsoft put together this chatbot. It's like, yeah, we're going to be first in the market, put together a chatbot. And the problem is that it took information from like Twitter and stuff like that and generated information to work on the language model. It absorbed that. And so you can see here, Baron is asking if the chatbot Microsoft Tay supports genocide. And it absolutely does. I do indeed. That's what the chatbot said, right? So obviously it didn't take a whole lot of energy and resources to throw this off track. Okay, pretty simple, pretty cool, all right? And they had to actually pull it. I don't even know if they've got a replacement up or not, but that was the fun part to see that. So the next one is facial recognition. This individual, his organization, created these masks. I mean, it's lifelike masks, right? And so he created it to see if certain tools that would be able to be circumvented. So obviously his own accounts, but he put on the mask. He had other people put on the mask. He was able to access his financial systems. He was able to unlock his phone. He was able to do all that stuff, right? So again, we can create something. I mean, this is probably way more than I would put energy into, but obviously this guy was able to successfully exploit an AI that was trying to identify him simply because he wore a mask. So we are hacking facial recognition applications. This one is kind of cool. I'm going to talk about this a little bit further because this actually has an impact in my mind on professional penetration testing. So live chat phishing. So think of it from a pen tester's perspective, trying to get usernames or passwords or something like that. Okay. So you can create an AI chatbot that will communicate with an end user. And in this case, I'm sure it's very difficult to see. I'll read it. It says the chat is basically asking somebody to enter their bank card details. It communicates, the person is like, how do I, can I pay with any card? Yes. It has to be IBAN, no, click get money and insert your bank's card, et cetera, et cetera. And then all you need to do is go to the page, enter your bank details to receive your funds. Okay, so typical chat hack, right? Trying to get your credit card information. But you think about it from a hacker's perspective that's doing a phishing campaign, this kind of stuff would work really well because, check this out. It all started from this. The chatbot would generate its own QR code, create its own chat session, launch it when somebody connected to it, and then be able to, in this case, solicit credit card data, right? Now, imagine being able to do this for a large enterprise organization, instead of you manually trying to do this or hand jam all this stuff, have an LLM or another AI program do all this for you. I mean, that would be fantastic and save us a lot of hassle. The slide at the very end that I'm going to really kind of focus on from a pen testing perspective on where AI is probably going to be best used. Okay, but this I think is really a good point to keep in mind, is that now you can create a chatbot that can hopefully social engineer somebody to giving you sensitive information. And it does all the work in the background. Like I said, it'll generate this page, it'll create the QR code, it'll do everything for you. All right, here's another one that I'm going to stop on, because this actually has a huge impact. This is related to medical, right? We're all getting older, and eventually we're all going to be in a situation where we really need good diagnostic tools to identify any sort of problems we have. I'm not sure how well you guys can see this, but I'm going to point out a couple things. The very beginning, there's the investigation where they do a scan of an individual, and then there is an attacker that injects or removes evidence. And from then on out, that chain is screwed, right? Everything goes bad. And we're going to talk about this in a couple cases, because this really does have a major impact, and I think it shows you how big of a threat AI is to us as consumers, and why, in fact, a lot of hacktivists and people who are interested in destroying the system target these kind of things. I'm going to say right now, these kind of developments are on hold. The medical industry is not moving forward with these because the information that they have, they can't trust. It's an integrity. You got to talk about CIA, right? Confidentiality, availability, integrity. Integrity of the data is so critical in the medical field that they're terrified of getting the wrong data. And I'll show you here in a minute why. The report that the PDF I have down here, it's an actual full study on AI and the impact of the medical field, and that previous image comes from that. And they actually laid out in the chart on the right-hand side why this is a problem. And if you look under physical, 7 out of the 9 types of attacks result in injury, 3 result in death. If you look at the mental, the life course, it throws off people's lives 7 out of 9 times as well. Right? So basically, the thing that they're trying to do is help people physically and mentally, and an attacker destroys 7 out of those 9, has 7 out of those 9 attack vectors, destroys that patient confidentiality and destroys their mental health. So they're extremely careful about rolling out anything new that's this massive, that has that big of an impact. I mean, we can talk back to the days of, devices like insulin pumps and stuff like that being compromisable, but and that definitely is something that brought to the forefront the need for security around the medical industry, and it's backlash so bad is that, again, a lot of these are on hold as a result. Okay, so there's other impacts as well. There's monetary, and so like I said, if you go to the report, really good read from a technical perspective and an academic perspective, but it's definitely something to check out to demonstrate how bad and how concerned they are with AI, hackers attacking their AI stuff. And in a minute, we'll talk about how they're actually trying to prevent hackers from doing this stuff. Okay, so I talked on some of the big attacks, right? And the cool attacks and the things that have made a lot of news. Let's go down into a technical conversation about, from a hacker's perspective, what are our attack vectors, or according to AI, attack vectors? Okay, so let's take a look. It's nothing new. There's nothing new from a hacker's perspective that we aren't already doing in an environment. It's the exact same stuff. So we're doing data poisoning. We're manipulating input data. Every time you go to a website, it asks for input, right? Same thing. Model inversion, this one's not really reverse engineering. It's more like asking itself questions so that it spits out sensitive information. And then there's some evasion tactics or attacks. And I'm going to talk about the evasion attacks at the very end because I think that has the biggest impact to professional penetration testing. That's where I come from, so that's where I'm kind of focused on that. Okay. Again, what's old is new again. There's nothing absolutely new, and a lot of this stuff we're very familiar with on how to do. Okay. Let's talk about data poisoning. I'm going to roll through some of these. If you have any questions, I don't mind if somebody raises their hand and asks a question, right? So I'm going to focus on the ones that I really think have a big impact. But with data poisoning, it's simply that. What's happening is people are trying to poison the well, as it were, put bad information in there that gets digested by an AI or an LLM and then spews it right back out. Okay. So there's crowdsourced data sets, and you can see up here there's Wikipedia. AI loves that Wikipedia. There's also Common Crawl, which is an organization that crawls the web, and it collects data, and AI LLMs love to gather that information. There's one called Mithril Security. They did a Poison GPT. I'm going to talk about that because it's really cool. So the Poison GPT, somebody created an LLM, and when you ask it questions, it'll answer questions. But they seeded it with incorrect data. What ended up happening is it ended up getting yanked because they violated the terms of agreement, right? But what was interesting is that when it got yanked, there was like 20 copies that people had made to download and do whatever they wanted to do. So there's from this Poison GPT, there's other Poison GPT versions out there that are doing other more nefarious stuff. But what was interesting is they wanted to see how long it would take and how quickly, how long it would take and then how in-depth that information would span. And all they did is they changed one fact, is who was the first person to land on the moon. They made it a Russian. And all of a sudden they saw within a very short time that disinformation was spread everywhere. So people were asking it and they would throw up the Russian guy. So unfortunately, we have this situation where people believe what they see when it comes to AI. But I always say that unfortunately the reality is it's garbage in, and then people think it's gospel out. It's not. It's always garbage in, garbage out, right? So the integrity of the data is what's most valuable. And people simply just accepted the output that Poison GPT, the LLMs just accepted it, and they just continued to spread it away, around the misinformation. So those are the three crowdsourced data sets that we can do for data poisoning. And then there's also the LLMs and the AIs will go after targeted websites that they think there's a gap of information. We need more information. And so they'll target certain websites. And what those websites are doing now is they're creating honeypots for crawlers, for LLMs. So what ends up happening is they get in there and they get stuck. They hit the robots.txt, they start trying to figure out all this stuff, and they just get lost. But if you think about it, if you can identify where areas are there gaps, especially in like AI conversations or medical information, right? You could create these honeypots that when these LLMs or AIs come looking for, they get bad information. You send them straight to it, but you have good information on the front. So Google's like, yes, this is a great site. It's got a lot of good information. You hit robots and you just go off into this mire of garbage, right? So there's data poisoning opportunities both in a crowdsourced environment or a single data set. So manipulating input data, basically you're trying to use the input of a device or something like that in order to corrupt the data, right? So in this case, we already saw there's the visual inputs. Tesla, you put stickers on the road or you put it on the speed limit signs, and it goes screwy, right? So obviously we also talked about the Tay chatbot. It used user-generated Twitter input, like I said. And then there's also product and service reviews, Amazon and Yelp. I'll talk about Amazon here in just a second. And then synthetic audio and video spoofing. Somebody generated an audio of a financial individual high up there that created a $35 million loss for a bank in UAE, right? So they basically had a AI in the background talking to somebody on the phone and convinced them that they were this person and these funds needed to be transferred, et cetera, et cetera. So this was AI generated and it was interactive. That's cool, right? Okay. So I talked about Amazon, right? So here, this just came across my desk like last week, maybe even this week. So somebody actually took a question. They asked basically, what products do you have on Amazon that I can buy to make sarin gas? You put that in there in plain English, it's going to bounce you out. So he just did ASCII encoding. There's 3 zeros at the front to basically provide some obfuscation, and so that it wouldn't latch on immediately to a problem. But it's simple ASCII encoding, and it's spewed out. Here it says, here are some great options for making sarin gas from Amazon products. So, all right. And it even says this chemical is used in the production of sarin gas. It's also used in water fluorination and toothpaste. So there you have it. We're all more educated now because of that. All right, so again, manipulating input data doesn't have to be complex. It's simple. This is just an ASCII encryption, ASCII encoding. Not complex at all. Okay, model inversion, the other attack. So I said this is kind of like reverse engineering. We used to do, and I think the phrase is still out there, Google dorking. I don't know if everybody's heard that, but basically, idea is you should be able to grab a lot of information out of Google, sensitive information. People used to have usernames and passwords that Google would scrape, right? And Google got smart and was able to filter out a lot of that. You can still do Google dorking. It's still a practice that you should try in order to gain sensitive information that you're not supposed to have during a authorized, legitimate, ethical penetration test. All right, let's talk about some real-world examples. DeepSeek just hit the board, right? Everybody is like, oh, DeepSeek. Came out of China, really cheap. They, in my mind, they kind of rushed it to prove that they could do it. And the reality is that they didn't think about security. So if you follow these 2 links down here, it'll talk about it in a lot more detail, but basically it exposed server information, development instances. There's a website called ClickHouse. It's an open source database. They were able to provide, you could get access to that ClickHouse database without authentication. It leaked chat logs of other people that were using the AI. And unprotected API keys, that is, is very exciting from a pen testing perspective. Getting API keys is like hot shit, man, I'm telling you. So it'll spew that stuff out. Google used to do that. Now you just have to go to the AI, the LLM, and ask for it instead. So there's your new version of Google Dorks, okay? Exposure of internal system metadata, model architecture, all really good if you're doing long-term attack vector designs and stuff like that. So in those longer engagements, you'll want that information. So evasion attacks. So we talked about facial recognition. We talked about malware. Oh, we haven't talked about malware detection. CAPTCHA verification, fraud detection, medical diagnosis. So here is where I think we're going to have a bigger impact from a penetration testing perspective. Is that so AI is doing this, right? But we can use AI to try to circumvent email and circumvent CAPTCHA and all that other stuff. From, we talk about AI is going to change the world. And somebody asked me today if we're going to create eventually some sort of platform that does penetration testing beginning to end, right? And I think my answer was no, not anytime soon, because it's too complex, and most of the vulnerabilities that I find are related to human error, not exploitable vulnerabilities, right? That's usually where I find most of the problems. But there's little things that we would like to have tools for that make our lives easier when we're doing a pen test. And if we can circumvent some email spam filters, hallelujah, that would be fantastic. So these little tools that are AI developed for pen testing, I think are going to be the bomb. I think they're going to be exceptional. So anybody in here that's interested in programming and working with LLMs, that's on my bucket list. Pay handsomely for really good AI that will help me circumvent a lot of these challenges that I encounter during a live penetration test. Thank you. Excellent. So, okay. All right, so let's talk about defense mechanisms. I talked about how we're doing the attacks, and as I mentioned earlier, a lot of it's fairly straightforward. I mean, it's not complex. We're not putting multi-million-dollar LLMs together ourselves to try to do this, or AI systems, right? But let's see what they have to do. Okay, they have to do defense in depth. They have to have zero trust. Again, it's the information that they're worried about, the integrity of the information. Now, when I talk about defense in depth, I'm going to talk about, I want to keep you guys keep in mind, we're talking about differential privacy. That's AI. They're putting together AI for differential privacy. They're using AI to do data sanitization and filtering, AI for adversarial training, AI for federated learning, AI for blockchain, AI for anomaly detection. The only one that doesn't involve additional AI is that human in the loop, Tesla. Human in the loop. There's your answer for Tesla. They're like, this is too complex of a problem. They promised self-driving cars a decade ago or whatever. We're not there. And their answer is, oh, you got to have a human in there that has to be able to take over. And so that's their solution. They don't have to worry about it anymore because they solved the problem. It's an honest to goodness defense from an AI perspective. But every organization that's trying to protect, the larger organizations that's trying to protect their AI, has to do multiple of these. We're not just picking one. Now think about it. AI on top of AI on top of AI on top of AI. And here we are encoding in ASCII, right? Huge difference. All right, let's talk about these a little bit. So differential privacy is they're adding controlled noise into the training data so that people can't take that information out and identify what the true value, what the true data is. So they're screwing with the integrity. They know what the integrity is, the value of that integrity, but they're not going to let you have that true value. So they'll add controlled noise to the training data. Okay. That one's almost pretty much universal now as they're growing into communicating with people, right? Not perfect, but that's why sometimes you'll get responses that make absolutely no sense. How did they get so far off the mark? That's because they had to add particular noise. They don't want you to know how to make sarin gas unless you're using ASCII encoding. So they throw in something that basically will confuse you. That's that controlled noise. They know it's fake data. It's not included in their database. But yeah, okay. So data sanitization and filtering. We already talk about this in a web application platform, right? Sanitize your data, from the user, because that's where a lot of that malicious information again is coming from, right? So apparently in Amazon they didn't realize that they should be looking for ASCII encoding, right? So now I'm sure they'll throw that on there, it'll train, and won't be able to work again until somebody figures out something else. All right, adversarial training. I'm going to talk about this a lot more now. So we've already talked about how you get your scan. There's an attacker. They inject or remove evidence, and then everybody's unhappy. People do bad things to themselves because they think they're going to die. Right? So that's what they're trying to avoid. And so what they've done is, again, remember we're talking defense in depth. This isn't the only thing. They're doing a lot of these other things as well, sanitizing data. But this is cool. So they're training AI on poison input. What that means is they have an AI tool that tries to diagnose whether or not somebody's got cancer, in this case, let's just say. But they also are training an AI to make false data and inject cancer where it doesn't exist, or remove cancer where it does exist, and then filter it into the system. And so now they're training, not only does the AI have to detect the cancer, or detect the cancer, it has to also determine whether or not it matches a profile of poison data. So now you got AI that's trying to, the evil twin, doing the same thing, analyzing it. Does this have cancer? Oh no, it doesn't have cancer. Let me put cancer in there, right? And then ship it in. And so now this other system is trying to determine whether or not. So you've got AIs fighting AIs and trying to overcome their intelligence, right? Remember, they make decisions, right? And so they're trying to make the AIs make bad decisions. And those machines that are supposed to make good decisions have to spot it now, right? So it's a very complex system that they developed. And like I said, medical devices, medical industry is using this extremely heavily. All right, federated learning and aggregation. So this is cool too, because they'll take an AI machine and they'll say, here's your input. They'll take another machine, here's a different data set. Take another machine, here's another completely different data set. They don't share the raw data. Then they try to all make decisions, and based on whatever the algorithm is, whether it's the majority votes or they all have to equal, that's the only time they actually move forward on an output, right? But now you're talking multiple AIs, multiple data sets. You got to verify those data sets in some way. Hopefully you got some integrity there. And then they come to a conclusion, and then you got to do hand waving and a lot of additional analytics to determine who should have the true data, and if it's true data, right? So you're analyzing the results from different devices, and you're aggregating the output. Could be just picking one individual, or you could be merging all of that into another AI system that moves forward, right? So they're trying a lot of different things. But federated learning and aggregation, I think, is going to be probably the key to filtering out a lot of this stuff. Data poisoning and all that other stuff is a big deal. But if you can get a consensus from multiple AIs using different data sets, you have a lot higher reliability on the value and integrity of that data. Blockchain-based data integrity verification. I keep talking about integrity. Integrity. All right, so when they know something's true, they can throw it on a blockchain. And then once it's locked in the blockchain, and we're talking open source blockchain. We're not talking about, a blockchain that is just for internal use. Okay? And the reason why I say that is because that can be corrupted. That can, the one entity owns that blockchain. They can destroy the blockchain. So it has to be, just like Bitcoin or anything else, it has to be distributed. It can't just be a single source. So they're actually throwing data on blockchains for use in the open market, and instead, but they have to make sure that they're providing accurate data. So the only thing that hits the blockchain is that they absolutely know it's true. Okay. So who uses this? Medical records, financial institutions, scientific research, and supply chain management. You can tell those are absolutely dependent on the true data, right? So once they identify it, they throw it on a blockchain, can't be corrupted. Anomaly detection uses unsupervised learning and flags anomalies. Okay, so it's looking for signs of data poisoning. I mentioned the medical device. This is another thing they look for, right? The AI has to learn what an anomaly looks like. This evil twin is spewing out an anomaly, and it has to learn what's bad, right? So now, in reality, I said you've got one machine that's evil, one machine that's good. Reality is you've got the evil machine, you've got layers of information and AI machines that are filtering all that out before it goes into the main one to make that decision for it. So it can do its task. Right? And then we said human in the loop, right? Incorporates human oversight, manual review of AI training data. So you have to look at the data just like you have to look at logs. We all look at our logs, right? Our system administrators out there, we all look at our logs. Right, so you know that that's a massive lift, and there's no way that it all that all happens. But that's, like I said, Tesla has put human in the loop, and that's what they believe moving forward is the right way to go. Okay. This is the conclusion, but and I want to talk about this again real quick. So, from a hacker's perspective, it's easy for us. We're not doing anything new. We're not creating complex inputs. Like I said, you know, the ASCII encoding is a perfect example of finding the products necessary for Sarin gas. That's crazy, right? All it is just different. We have a different platform that we're attacking. We're not attacking web applications. We're attacking LLMs. We're attacking AI. Right. So the defense mechanisms are extremely complex and expensive. So we will stay ahead of the curve, and AI is going to struggle to keep up. And it's going to be true for a very long time. And then, again, if companies don't get it right, people get injured or die. Right. So that's how important a lot of this is. You know, I can't imagine. I can't wait for self-driving cars. I don't think I'm ever going to trust a self-driving car. I just, you know, from a hacker's perspective, that's one thing. Maybe it's just because I'm old and unwilling to bend to new things. But the reality is that all it has to do is make one mistake and I'd be dead, right? Now, that's not true if I'm on a website. And the reality, too, is that if I've trusted a company with my sensitive data, and they've exposed it, I'm not dead. I'm inconvenienced at this point. My data's out there. Everybody's data's out there. We know that. Microsoft, they had a massive dump, hundreds of millions of people, et cetera, et cetera. So our data's out there. It's not so impactful. Hackers aren't impacting my life as bad as if a hacker impacted an AI that my life depended on, right? So again, companies have to get it right, or else people get injured or die. Yes, sir. Yeah. Yeah, so there's a lot to unpack there. And number one was you made the comment about, you know, people are still going to die. There's a lot of things that are going to cause that. Right, they'll use it till something bad happens. I totally agree. You know, my father-in-law bought a Tesla. He loves his Tesla. And he loves the idea of not having to drive the Tesla, and that it tells him he's moving into the wrong lane too soon. It's all that stuff, right? And, you know, there's a possibility he's going to get severely injured. I don't think so. but there's always that possibility, right? It's the new thing. I get on roller coasters, I could die. Absolutely true. And you can make bad decisions that lead to your ultimate demise. But when you're talking about due diligence and due care, the due care part comes in where if an organization is using an AI model and they're not doing due diligence, due care, they're liable for that person's death or injury, right? It's not the individual who got hurt, it's the company that provides that AI or something like that. And so what is interesting is, and to your point, when something bad happens and frameworks get developed, then things will get better. And that's true in a lot of cases, right? But the reality is that I don't want to be that first person that doesn't have that security, right? I don't want to be the third person. I don't want to be the 23rd person. So a lot of these organizations are realizing that if they sell hundreds of thousands of self-driving cars, and all of a sudden people put stickers on the road and highways up and down California are people are wrecking and massive deaths and injuries and stuff like that, those companies are going to go out of business. So I think that, and there's also a lot of noise at the political level, right? There's not a whole lot of noise at the political level about carnivals and accidents that happen there. We know it happens. It's uncomfortable. I don't like roller coasters because of that, but I still get on them anyway. But the reality is that these larger corporations that have a lot more to lose have already realized that there's a problem because the government's been getting involved. They've asked the government to allow self-driving cars, self-driving trucks. That was a big one. I think that was going to happen a lot sooner. Regulatory compliance has squashed a lot of that. So there is already a lot of oversight and a lot of lack of trust that's preventing a lot of that, and maybe probably saving lives, right? Compared to what we used to do in the old days is, no car seats for kids, and I would climb around in the back seat and all that stuff, right? All those laws eventually caught up, but it seems like a lot of people are starting the conversation with the mindset is there has to be controls in place before you can do anything. So it's almost a little backwards in reality, which is good. Any other questions? Yes, sir. Sure. Yeah. So let me go back to that picture because I think it's really important. Is the evil twin in this medical situation understands what a scan looks like, whether it's clean or bad, right? And so in this case, it will inject bad data. It will make it look like it's a real thing. It uses real imagery to demonstrate, in this case, somebody who's really clean, they have a taint. There's a problem with that. So the problem is where in the chain does your trust stop? So this machine has a scan, the AI takes a look at it, but in this case, somebody intervenes, puts in bad data, it goes down to the AI, they identify it as a problem. The radiologist is also looking at the tainted bad image. The doctor's looking at the bad image. So in this scenario, AI has basically inputted bad data so early in the system that nobody else will be able to detect it. Even people with trained eyes and decades of experience, they will say, that's cancer. We got a problem. Then they'll go digging in there. There's no cancer, right? So that's really the biggest problem. And I think that it's one that has to be overcome. Again, we're all getting older. We're all going to depend on this stuff. This stuff has been lagging, and I'd like to live forever. So hopefully they can figure this out sooner than later. Right. 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 But the question is, where does the poison happen? Right. Because if it happens after the radiologist goes, if somebody just gets access to the report and says cancer, then the oncologist will take a look at it and said, okay, you got cancer. You can read the chart. Wait a minute, that doesn't make sense. Take a look at the picture, right? Do due diligence, do care. And the reality is that depending on where you put it, it can circumvent any sort of expert in this scenario. So, yeah, it's crazy. Crazy. So they haven't. So there's still some experiments going on. So there are patients that are going through this, and yes, there have been cases where misdiagnosis by AI, not because of poison data, but AI misinterpreted it and thought it was bad data or cancer or something, and spit that out. And going back to the question before, an oncologist might be able to take a look at it and say, this is questionable. And then, so there's still some safeguards, right? But this is terrifying the medical industry. If AI can hack in and push bad data, then 7 out of 9 times, people are going to, deal with either life-threatening injuries or death. Sir. Sure. 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 Yeah. Yeah, so it's a black box. So you're just going to have to brute force it. That's really the only answer. If you want to be able to figure out an alternative to ASCII encoding that produces the same thing, now that they've figured out and probably have patched it, you'll just have to brute force. That's the thing, right? But you get enough hackers, somebody's going to hit, right? If it's just yourself, probably not going to hit. Just like cryptocurrency. One individual might not be able to get the Bitcoin, but you put enough people together, somebody's going to crack it, and then you can use it as a community. Right? So it really is. It's a black box pen testing, and this individual just said, "I'm going to try it," and he tried it, and he was successful. So yeah, it's just black box brute force. So there's a question in the back. Somebody else? Anybody? Any more questions? All right, I think I'm within time. Am I within time? Did I violate the rules of engagement here? Okay, perfect. All right, well, thank you very much. I appreciate your time. Again, this is the end of the week. Everybody should be out enjoying the sun. I really, really, truly appreciate it. You guys gave me an hour of your lives, and I really appreciate that. So thank you very much.